like 10.6 plus 8 plus 12. And there is my perimeter. 30.6 is the perimeter of the smaller triangle in there. Now moving on to the next page, if we're given these guys are the midpoints of the sides. And so you need to go through, and since we know these are midpoints, what we know is that the side opposite it is going to be double the length and parallel to the side. So I've got to find a line that is parallel to ML that's going to go through point N. So that's what we're going to do. Well, first thing we're going to do is I'm going to I'll use black lines over here. Since ML, if I find the slope is down 1 over 2, and that's you can just do that by counting, then from N, if I go down 1 and over 2, there is half of the line I need. If I go from here up 1 and back 2, there's the other half of my line. So there's my line that is parallel to ML. Well, if I want to find this line that goes through L here, through point L, I have to look at the slope opposite it, which is up 1 and over 3. So from point L, if I go up 1 and over 3, hey, look at that. They run into each other. And if I go down 1 and back 3, which is the opposite direction, I get the other half of my line. So there is the other side of my triangle. And here, so I only have one more side to go. Hopefully these two guys will connect, but we're going to check just in case. And so to go through M, I need to go up 2 and over 1. So if I go up 2 and over 1, there's 1. Hey, that connects. If I go down 2 and back 1, there you go. So the black lines are my triangle that goes through those midpoints and are basically these guys, the red lines, are the midsegments. And so you're going to have to be able to go forward and backward on these. So please pay attention to this. If you need to rewind it and watch it again, please do so. And then last but not least, we've got some walkways here on a college campus. And basically what we've got is that the midsegment AB represents a new walkway that's going to be constructed on the campus. We need to find the coordinates of point A and point B. So you'll look at this. We are going to find, remember that from O to Q is some line, and if we find the midpoint of that, that would give us the ordered pair for the point A. I'll move this out of the way so that we can have some work here. So if I want to find A, point A, I'm going to use my midpoint formula, which is add my x's together, so 0 plus 2, and divide by 2. If I want to find my y values, I add my x's together, or add my y's together, and it's 0 plus 8 divided by 2. So for point A, we end up, it looks like, with, if I simplify this, I get 1 and 4. So there is point A, and it should be the letter C. If I want to find point B, the midpoint of point B, well, you could count. I mean, if you can see this, you could count. You can count these out, but I'm going to use the formula because I'm kind of a formula type person. So if I add my x's together, I'm going to say 10 plus 2 divided by 2, and my y's together, 8 plus 4. It's supposed to be an 8. I don't know what happened to it, but 8 plus 4 divided by 2. And if I combine those, 12 divided by 2 is 6. And 12 divided by 2 is 6. So the coordinates for B should be 6, 6, which is right here. So there's my point A. Point A is 1, 4, and point B comes out to be 6, 6. So it says each coordinate in the plane represents 10 yards. Use the distance formula to find the length of the new walkway to the nearest whole yard. So we can't really count this because we're kind of in the middle and it's on an angle. So we need to go through and do the distance formula. So if you want to do the distance formula, feel free. I'm going to show you a little shortcut with the distance formula if you don't remember it. But the distance formula for the length of AB, and I'll set it up for you, but I'm not going to solve it all the way. I'm going to show you the shortcut. The distance formula is the ordered pair, the x's in A and B subtract from each other. So 6 minus 1 squared plus the y subtracted from each other, 6 minus 4 squared. So slope is really the only one that matters, what order you put these guys in. And so we could go ahead and simplify it, and maybe I'll come back and simplify it in just a second. But I'm going to count because I'm going to use Pythagorean theorem. Remember that they said if you look at the scale of this, every point is a distance of 2. So that means I'm going over 1, and then 3, then 5. So I went a total, to get over here, I'm going over 5. And then I'm going to go up 2. So that means if I made a right triangle out of this from A to B, that side is 5, this side is 2, so 5 and 2. If I use Pythagorean theorem to find AB squared will equal 5 squared plus 2 squared. And AB squared then equals 25 plus 4, which AB squared is 29. And if I take the square root of both sides to get rid of the square, AB comes out to be the square root of 29. Well, that works anytime if you have it drawn out. If I don't draw it out, then distance formula is the way to go. But you could still draw it out and do it. But you'll notice, look, if I take 6 and take away 1 underneath my square root, I get 5. And I'm going to square it. If I take 6 and take away 4, I get 2. And I'm going to square it. So AB, in this case, will come out to be the square root of 25 plus 4, and hopefully you can see that if I combine those together, I get the same thing. So that means square root of 29, I would have to come up with approximately what that is on a calculator. So let me see if I have my calculator here. So the square root of 29 is 5.38. 5.38 is basically what we're looking at. So 5.38 is the length of that line. Is the length of that line. But they said that each point, so there's 5.38 little squares. If I multiply that by 10, because that would be how many yards it is, it would be 53.8 would be my final answer. 53.8 yards, and to the nearest whole yard, I would say 54 yards would be the actual length of that path that we're talking about. So here we are at the out. Oops, I skipped the out. Here we are. Somewhere we're at the out. There it is. So we're at the out for the day, and it says the figure shows a triangle with one of its angle bisectors, and so we need to find the measure of angle 1. Now this goes back to what we did before. So what do we know about the two angles? Well, if it's an angle bisector, we know that the two angles are equal. So 4x plus 5 is going to equal 5x minus 2. If I set those equal to each other and solve for x, I could then find angle 1 and angle 2. So following my steps of algebra, subtracting 4x across the equal sign, I end up with 5 equaling x minus 2. And if I then add 2 across the equal sign, x equals 7. Well, that's not the answer. That's just what x is. That's just part of it. If I want to actually find out what the measure of each angle is, if I want to find angle 2 is going to equal 4 times 7 plus 5. Angle 1 is going to be 5 times 7 minus 2. Well, 4 times 7 is 28, plus 5, I believe, comes out to be 33. And down here, we end up with 35 minus 2, which is also 33, which would make sense because they told us they were angle bisectors. Angle bisectors mean it cuts it in half. So thank you for listening in on our webinar today, and I will see you guys in class, and I will talk to you guys very soon via video. Thank you very much.